Okay, so to finish up the 4.2 notes that we were doing in class today, we were learning about combining like terms. So we can combine like terms whenever they are the same variable to the same power. So on this next one, keep in mind that there is a 1 technically in front of this a, and I think that's where it can get a little bit tricky. So checking to make sure that these are like terms, they both have the variable a. A has the power of 1 on it, so they are the same. We can combine them together. So I would have the 6 and the 1, take their coefficients and add them. 6 plus 1 gives us a 7a. On the next one, it's a little bit more complicated. They've added in a lot of variables and additional terms. So I use shapes to help me keep track of things that are considered like terms. I'm going to begin by looking at the x's. So I've got a 2x, and it's x to the first power, and then we've got a negative 6x, which is also to the first power. So those are considered like terms. I'll be able to put those together. And so I'm going to go ahead and start keeping track of them below. So the coefficients are 2 and a minus 6 with an x on the outside. Next, we've got y's that can be combined. I've got 5y and I've got a 3y. So down here, we're going to take their coefficients, the 5 and the 3, and put them together with a y on the outside. And then lastly, we're going to deal with the constants. And like I said, I like to use different shapes to help me visualize what I'm combining. So I've got a 2 and a 7. So I'm going to combine the 2 and the 7 together. Those are going to be my like terms. So notice I grouped the x's together, the y's together, and then the constants together. So combining my like terms, 2 minus 6 is a negative 4, carry down its x. 5 and 3 make 8, carry down its y, and 2 and 7 gives us 9. So we have now simplified this by combining its like terms. We grouped them based on their variable, and the variable had to be to the same power. Let's look at D because it's taking it up another notch. Not only do we have multiple variables, we also have some parentheses in here that we need to get rid of. And we learned in 4.1 to get rid of parentheses where we can't combine the stuff in the inside, we need to use the distributive law, which says we're going to take this negative 2 and multiply it to both of the pieces, both of the terms in the parentheses. And we're going to do the same thing with the negative 1. We're going to distribute it to both of the terms. So we've got negative 2 times x makes a negative 2x. Notice that I'm showing a little bit less work than what we were doing in 4.1. You can do some of that in your head. If you need to show all of the steps, then feel free to do so. Negative 2 times 5 makes a negative 10, and the 5 had a y on it, so I'll carry down that y. Negative 1 times 2x makes a negative 2x. And negative 1 times negative 4y makes a positive 4y. We just had to change the signs in that second set of parentheses. Next, I'm going to group the like terms. So I'm going to put a circle around anything that has an x. Okay, that one's an oval. Maybe I'll make a circle. So I would have down below negative 2 minus 2 with an x, and then I'm going to put a box around the y's. You can use any shapes you'd like, or none at all. Maybe you can see it without. So to that, we're going to add the y's. So the coefficients are negative 10 and positive 4 with a y on the outside. Negative 2 and negative 2 make a negative 4. Carry down the x. Negative 10 and 4 make a negative 6, so it'd be minus 6y. Okay, I know C and D are kind of tricky, so please reach out if you have questions or if you'd like me to work through more examples with you. I'm going to go ahead and keep rolling with these examples since you can pause the video at any time. We're going to practice some translating. So we're going to let x be a number, and we're going to translate the following and then simplify the expression. So we have 3 times the number, which we don't know, we're calling it x, minus 4, plus twice, so 2 times the number. So let's rewrite this with it less spaced out. So 3x, because 3 times x, minus 4 plus 2 times x, so 2x. To simplify, we combine our like terms. So I've got 2 terms that have x's, and they're x's to the first power, so I can combine them together. So 3x plus 2x's. So 3 plus 2 gives me 5x's. Carry down that constant of minus 4. The next example actually wants us to go the other direction. We want to write this as an English sentence, and then we'll simplify. It doesn't make sense to simplify it, though, with an English sentence. So you could simplify first and then write it. But we're taking the number, since there's an x, we don't know what x is. So the number minus 5 times, and I want to imply that there's going to be a quantity or parentheses, so I'm going to use the words the difference of, because not only does that mean subtraction, it's going to imply that it was a quantity grouped together. So the difference of the number, because it's x, and 2. And so we actually had a discussion in class about that and. The and is telling you where to put the subtraction symbol, the difference, that wording. There are many right answers to write this English sentence, so please don't think this is the only way that you could do that. Let's simplify it. So we've got 5 times a quantity. We want to get rid of those parentheses, so we needed to distribute that negative 5. So I'll carry down the x, and then we've got negative 5 times x, so negative 5x. And we've got negative 5 times negative 2, which makes a positive 10. We want to combine our like terms, so we've got an x here, and remember, there is a technical 1 there, and then we've got a 5x. And so if we take 1 minus 5, that gives us negative 4. So we've got negative 4x, carry down that plus 10, and we've now simplified it. On this next